All right, an ice sculpture in the form of a sphere melts in such a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. So let's just go ahead and note what that is, right? So that's the volume is decreasing at a rate. Well, that's dv dt, and it's a negative 2 pi, right? Because it's decreasing, right? So decreasing at a rate of 2 pi cubic meters per hour would be negative 2 pi. At what rate in square meters per hour is the surface area of the sphere changing? Or decreasing rather, at the moment when the radius is 5 meters. Okay, so then they did you a solid and they gave you surface area and they gave you volume, right? So that's nice of them, right? So we know volume is 4/3 pi r cubed, right? And we know surface area, which I'm just using SA as a single variable, is 4 pi r squared. So they ask, what rate is the surface area decreasing? So the thing that they want, right? The thing they want is d surface area, dt, at the moment when radius is 5 meters. When radius is 5 meters, right? That's what they want. So the first thing I'm definitely going to need to do, since I have dv dt as a piece of information, I really need to differentiate and find out what dv dt would be as an equation. So dv dt is going to be, I drop the 3 down in front, and I end up with a 4 pi r squared dr dt, right? So I recognize that this is a negative 2 pi, right? That's my dv dt equals 4 pi, and they say constant rate, right? So r squared dr dt, right? So I can actually find dr dt at the moment when I can find dr dt at the moment when r is 5, if I want, right? And we'll talk about that in a sec, right? But so r is the only unknown, but I could find dr dt, so we could find dr dt at the moment when r equals 5, if we want, right? We could do that by solving for dr dt. So negative 2 pi over 4 pi r squared is my dr dt, right? And so at the moment when r is 5, which is the moment I'm going to be using in a little bit, my dr dt is, I could actually cancel the 2 with the 4 and the pi with the pi. So I'm just going to get a negative 1 over a 2 times 25, or a negative 1 over 50, right? At the same time, I want d surface area dt. So if I differentiate this, I get the derivative of surface area with respect to time is an 8 pi r dr dt. Well, all I need to know to find d surface area dt at the moment when r is 5, right? I need to plug in r is 5, and then I would need to find dr dt at the moment when r is 5, but conveniently I've already found that, right? That's a negative 1 over 50. So I seem to get a 40 pi over 50, right, with a negative in front. So I think I get a negative 4/5 pi. Now, that's not an answer choice, right? So that's not going to be a choice. The reason it's not going to be a choice is because, so this negative is because it's decreasing, right? But the question asked, how fast is it decreasing? So the negative is because it's decreasing, so it's changing at a rate of negative 4 pi over 5. Or the other way to say that is decreasing at a rate of positive 4 pi over 5, because the negative was implying decreasing. So it's answer A. But again, that's a lot of math to get to that one. Sometimes there's a nice shortcut answer, and this was not a problem where there was a shortcut at all.